We're recording. All right, let's get going. Anybody got a problem to start on?
6.
Number 6.
One of them from 6.
Let's look at number 6. Some of them might already be done. We can rework them. Even if they're already done, that is okay. We can rework them still. Anyone from number 6? I'll try to find one that we didn't do last time.
Or one that looks similar to the test.
Yeah, we did. Let's do. Actually, hang on. What is that? Graphing rational functions? Graphing rational functions. I'm going to find a different one. No, this is a good thing. Boom. This is a great one. Wink, wink. Exactly. So even if you're doing this, maybe write this next to number 6. Maybe write it on your white paper. Maybe write it in both places. I went online and found this because I think this is a good type to do. So this is still example number 6, but I just went and found a more apropos one for what we're doing. So this would be 12 o'clock hour. 12 o'clock review. If you want to go back, I'll post these as well, the PDF when I'm done, so you can have all the notes from the video as well, and you can just scroll through and look. So there's 12 o'clock review starting, and this is still for number 6. It's just more looking like what I think you should study. Okay, so the first thing we should do before we even it did say graph, right? I believe it just said graph the rational function.
No. Yeah.
All right.
Yeah.
So the first thing before you can even graph is you got to know a little bit about what the 6th grade math or 9th grade, what the 9th grade math is. This is not a 9th grade problem, but if you were just to look at say that, it looks a little more like a 9th grade problem. So what do we do with that problem itself? It starts with the F. Yes. Which, that also starts with a factor is that word. The word defined as zeros is called factoring. So we get x what? Looks like minus 3 and plus 2. And what about on the bottom? Oh, crap. This isn't like the test because of this, the thing that just happened, but that's okay. We can still study it. The thing that happened doesn't have one of these. But that's okay. We can still practice it. Okie dokie. So here's what we're going to do. We're going to take that. We're not going to do anything with it yet. We're just going to leave it like that and try to remember the 4 things that can happen. There's 4 things that can happen. And the test will walk you through them, saying, hey, find the x-intercepts. Find the y-intercept. It's not going to tell you how to do it, but it's going to tell you, first find the x-intercept, then find the y-intercept, then find the horizontal asymptote, then find the vertical asymptote, then graph it. So your brain has to know how to do each one of those steps. So what is the step to find an x-intercept? Set it equal to 0. Absolutely. Actually, it's even more specific than that to say set the top equal to 0. Yep. Those 2 things will get you the same answer. Set it equal to 0 and set the top equal to 0 means the same thing. This is just a little easier for us. So x minus 3 equals 0 gives us x equals 3. And x plus 2 equals 0 gives us x equals negative 2. So those are your x-intercepts of 3, 0, and negative 2, comma 0. With a little caveat on this negative 2 because something's going to happen to it. There's a little caveat there that we're going to see when we do the vertical asymptote that's going to say, what? Which one is it? All right. What about y-intercept? How do you find that? That's actually easier. You plug in 0 to the x's. So you'll get 0 minus 3, 0 plus 2, 0 minus 4, 0 plus 2, and you'll get something like negative 3 times 2 over negative 4. 3 over 4. So your y-intercept is actually 0, 3/4. Okie dokie. 2 more things.
The asymptote.
Vertical, yeah, let's do vertical first. I don't know why, just because I've already written it. Which one is set?
Set the bottom equal to 0.
Bottom equals 0 gives you that. So we've got x minus 4 equals 0 yields a x equals 4. And x plus 2 equals 0 yields a... Gasp! How could it be a non-existent point and a 0 at the same time? It's that special word called a hole, or a removable hole. It looks like that. I'm going to draw it next to it, actually. So right here, we just know we have a hole. Because it does both things, it's called a hole. Or if you want to remember, like, hey, look, we can remove it from the equation because it cancels out. It's another way you can think of it as a hole. There's one more thing to know / plot. Horizontal asymptote. And for that, we go back to the very, very start. But we don't even use our factored thing. We go back to the non-factored thing. And we go, chugga chugga chug, chugga chugga chug. Look at the exponent. Same?
Yeah.
Bigger or smaller?
Same.
Okay, so same means, yes, coefficients. Bigger. Top means infinity or none. Bigger. Bottom means y equals 0, y equals 0. So what is our actual fraction here? I think it's x squared over x squared, right? 1, which if we want to write that prettier, it's technically the line y equals 1. And I think we're groovy to graph it now. Where are some things we can plot?
We can put the vertical asymptote.
We can plot the vertical asymptote of
4.
4. What about the vertical asymptote of 2? Or negative 2, I mean.
No.
It's not actually a vertical asymptote, is it? It's actually a freaking removable hole, which we will remove in a second.
Wait.
Wait for what?
Never mind.
Okay. What else can we plot? Horizontal asymptote of y equals 1. Okay. What else can we plot? X-intercept? 3. Is that after or before that red line?
Before the red line.
So it looks kind of like that. Okay. Y-intercept?
Why couldn't you plot the -2, 0 again?
-2, 0?
Yeah.
Why can't we plot the -2, 0? Because it's a hole, it's not a 0. Something will happen unique over there at -2. Something will happen. We just don't know what it is yet. All right? I think we need to find more clues. I mean, I think I know what's going to happen over near that red side.
It's gonna go down.
I think it's going to go down, don't you? And then it's going to go like this. But whoa, what's going to happen there? And actually, without even testing any points, I know what's going to happen on the right side.
It's gonna go on there. No, it's gonna go like this.
Top or bottom?
Right?
Top or bottom?
Top.
Why top and not bottom?
There's no x-intercept on the other side of the vertical.
Because look right here. You see where it's going to cross? How could it go on the bottom and not cross? Would it just look like this? We've never drawn that shape. Would it look like this? Like, we've never drawn... It can't go on the bottom without crossing. There's no shape we know to draw that can do that. I guess they could go like this, but we just said the horizontal, it better approach this. Yeah, so it's got to go on the top. But I don't actually like trusting myself. I'll always plug in that one extra number to see. So I think 5 would work. And you just plug it in and you check, and I guarantee you it'll give you a bigger than 1 number. Cool? Let's just graph in those things. There's another one earlier where you can go and watch the video, and if we have time at the end and we get done with all the types of problems we want to see, we can do another one. The earlier one looked a little bit like... I actually don't know. Oh, that's funny. Y'all both asked the same starter question. They also asked for 6 first. The other one we did look like that, which is one of those triple sectioned ones. Totally possible as well. I'm pretty sure it doesn't have a removable hole, just if you're studying at home. Pretty sure. But I do know it starts with factoring the top and the bottom with nice, easy factors. So I can tell you that much. All right, what else are we looking at?
10.
Number 10. Find the domain of the function. All right, hang on a second. Let me just erase this real quick. Boop. Okay. Find the domain. As soon as you see that domain, I think of those 2 words. Oh, I got to erase that, actually. As soon as you see domain, I try to think of, well, wait a second. What would be the friendliest, nicest domain? That's usually what we want, right? Except for every once in a while, there's a bad number keeping us from having that. Every once in a while, you'll get a bad number thrown in the mix. So, you want to do A or B? Well, B doesn't make sense, actually. It's probably supposed to have an L in there, but you could find the domain of that function, too.
A.
All real numbers. A? Okay. Bless you. So what is keeping A from having a perfect domain? The natural log. The natural log is keeping it from being perfect. So we have to decide what numbers can't go inside of a natural log. What numbers are not allowed inside of a natural log? Yes. And? It's okay. That's what we're doing today for. So the inside of a natural log has to be bigger than or equal to 0. Nope. Not even equal to.
Bigger.
Equal to is allowed inside of the square root. Bigger than's natural log, period. So that's all we have to do. That's literally, as if you can remember that, you're good to go. 2t minus 3 better be bigger than 0. Solve for it. Do a little plus 3 action, plus 3. 2t is greater than 3. Do a little divided by 2 action. T is bigger than 3 over 2. I think 6.
It's 10.
Sorry, it's 10. 10a. And how do we write that in terms of domain formation? You know how to write domains?
Yeah.
How do you say that something's bigger than 3 halves? And then end with infinity? Lost it. But there are other things that can make you not have a domain. I don't know if they'll show up. There's 3 things for the domain. Domain, you check 3 things. You check for,
Bad numbers.
yep, well that's all of the 3 things are bad numbers or undefined.
Negative. No, not negative. Not negative.
I just like the idea of negatives are bad. just if it's got a negative, get rid of it. Yeah, that's the first one we usually talk about. Some number over, so like 3 over 0. That's bad, right? Second one. Which it comes from what, though? For people that...
I.
A negative where? Negative 4 under here, right? That's the bad thing. That's the bad thing. So what's the new bad thing we just talked about?
Ln.
Well, it's not just ln, it's any log, right? So the log of negative number, the ln of a negative number, log of 0, or the ln of 0. Is there a fly buzzing around you? Yeah, it was over here a second ago. It's like fast. So those are the 3 things, 3 bad numbers. Really not numbers anymore. They're more like concepts or undefined, restricted. 3 restrictions on your domain. Well, the other one's just all the argument of the log has to be bigger than 0. That's one thing. The natural log is just log e, so technically the first one takes care of the second one. Yeah, sure. Oh, no. I thought you just meant, can you bring like a note card? You bring a note card. I have a note card with you. Not like the note card police. Can I have writing on it? You can memorize all the stuff and then write it on that note card really fast. No, because I can't let you have the note card on the test because a good chunk of the test, is just blanks. It's not even with math problems. It's just blanks where it says list E rules, ln rules, log rules, exponent rules. We had so many random, and it doesn't even say which type of rule. There were so many random rules that were associated with it, right? Like, you know, like the little like ln of e equals what?
Oh, you mean rules as in just like so
Like
it's E or
it's 1. Yeah, that's a rule, right?
oh, okay.
Or like there was another rule, like the log of a times b equals what?
Maybe.
Log of a plus log of b. That's a rule.
If there's no base for log, that's 10.
That sure. You can say log of x is technically equal to what? Log 10 of x. That would be an accurate rule. I agree. And I just give you a whole page, and I say, hey, whatever rules you got, list them. I think, and then, I mean, if you can do like 1, that's not good. If you can do like, I think I'll give you the number there are. But every once in a while, someone will come up with something that's true, but I didn't like right, so I'm like, oh yeah, cool. Not
Well,
like,
we will have unit circle, right, on this test.
yes.
Are you gonna ask about period?
That's about what? The period being 2 pi over k. I think that's on one little sliver of it that's like worth a point or two. It's not the chunk of it
So,
by any means because we only did it for a day.
can I have like a blank page on the back so we can like write the unit circle?
I'll bring blank paper. Oh, I could just put a blank unit circle on it and make that question 1.
Oh,
That's more fun. Wait.
Do that.
A filled in just there with like 1 or 2 blanks on it and say fill out these 1 or 2 blanks.
No.
That'd be too easy. All right, let's keep going. We got to use our time wisely. Number 12. Oh, yeah, it doesn't make sense. Yeah, no, it was definitely a typo. In the class before, we said maybe the original question was, what's the log a equals 3? Write that in exponential form. How do you get rid of a log? You put the thing underneath it, right? You take the number that is the base and you put it right here. So how do you get rid of log to get a by itself? What number do you put there? 10? And it goes away. So 10, and it goes away. And now you've got a equals 10 to the 3. I don't know if that's the... Did you get the same answer?
No, there's just a complicated way of doing something. You could have just converted it to exponential form since we were doing that.
That's what I did. This is just a different way of writing, converting it. You got the same answer doing your thing. Or the original, like... Yes, you're right. Convert it to exponential form is true. What's up? What do we got?
Let's review 1 from 14.
What, the laws of log stuff?
Yes.
Okay. I did C already, so let's do A. Golly. So much. All right. Let's apply some log rules. You want to do division first? You want to do multiplication first? You want to do the other rules? I think we should do division first. It's touching everything. Like this multiplication sign is only touching these two things, right? And this cubic is only touching the y, and this squared is only touching the z. But this division is pretty much touching everything. So let's do that first. Let's go log And I'll do the first half, and you got to tell me what happens after this. You closed it up on the top. So what do we do at the bottom? Absolutely. Minus log. Okay, so here you go. If you're talking about that thing I just said was going to be a thing, what's the rule? What's the rule that goes with that if you're going to write the...
Division, yes, subtract.
But how do you write that rule?
Log division.
Pick...
Log fraction.
But you want me to write the word fraction? What do you...
No, just write a fraction. That's what I'm saying.
But give me a letter or a number or anything. A over B? Cool, that's a great thing to pick. If you do X, Y, you'll still get it right. I can see. Or S or T. People do different stuff. It's fine. What does that equal?
A minus.
Yeah. So there's an example of, like, you're talking about that note card. The only reason I can't let you bring a note card is literally because, like, making the note card is half of the second part of the test. The non-calculator part, it's not even solving answers. It's just like, hey, list all these rules you can remember. And it's not even like 100 is all of them. I don't know if it's going to be 80%. Like, it's just going to be, if you can say, like, yeah, I remember a lot. I might have forgotten one little rule. That's okay. But if you remember one rule total, then it's like, that might not be so good.
We can take that.
Now what?
We can take that 3, right?
No.
Or not yet.
There's another rule before that. But you're right. We will try to do that in a second. There's an invisible one. There's a sucky invisible thing happening still. There's an invisible multiplication right there, right? I know.
Separate that too?
Yep. So what's that separate to? Log of X?
X plus log 1.
And now we can do what you were trying to do because that looks like better to do it.
Mm-hmm.
Doesn't it? Were you hesitating because of the X?
Yeah.
Yeah. You were right to hesitate because of the X. Because that 3 is not touching the X. But now you shouldn't hesitate at all to look at this 3 and say, I can do something with it. Yeah. What can you do?
You can put it in front.
Boop. That's a rule too. So there's 3 rules we've already talked about and one problem that you could write. Now, will there be a problem like this on the first half? Yeah. But the second half is more like, bless you. So then doesn't that 2 also go to the front?
Yes.
So we end up with log of X plus 3 log Y minus 2 log Z. That might be my favorite type of problem we've done. Like that little puzzly stuff. I really like them. Wait, there's 2 more rules that we could write then. Log of AB better equal log of A plus log of B. Right? And log of A to the B, better equal B log A.
That's the cross.
I don't think there's a cross. I just think it's it's that shape, that rainbow shape I drew there to the left. If you have an exponent, it's allowed to just go to the front. Don't ask me why. I know which cross thing you're talking about. No, that's what Catherine was talking about earlier, which was the log. Here, wait, Catherine, will you explain how you did? What was that first one? ln of A, log of A equals 3. This is what you're talking about, the cross thing. Explain what you did to solve for A.
I mean, you have the base is 10.
Base is 10, so you wrote 10.
Yeah, and then the answer is the exponent, so you put 3, and it equals A.
Nice.
That's, yeah.
That's a rule.
It's the same number of writing things. It's about the same number of writes. I would say that, and I don't think one's right or wrong. But it's just 2 different ways to do the same thing. The way I do it is 10 raise, cancel. What you do to one side, you have to do the other side. So you're left with A equals 10 to the 3rd.
So you don't show any of the other ones.
That's true.
All right, nice.
Okay, sorry. That's what you were talking about crisscross, right? Yes. This is not like that. This is called, boom, boom. These 3 things were called log properties. But the crisscross thing is literally the definition of log. That is the definition of what a log is. A log is a way to rewrite an exponent so that you can type it in your calculator. That is, so this, the top things is some stuff that you can do with a log. This is just straight up the definition of what a log is. A log is, hey, what can I raise this to get my answer? That's what a log is.
In the definition thing, that's not going to be on the test.
No, I mean, that would count. If you wrote that, that counts on that second page of just like,
But the questions that has been asked is like, what are like math is involved.
I don't know, maybe. Yeah, I think that type of question would look something like a definitional log would look something with a log where it has an equal sign. It's not saying memorize it right here, like boom. That would be along the lines of definitional log. So like for the first one, how do you get rid of that log? Raise it by 10, it goes away. Raise it by 10. Now you've got yourself 2x equals 10 to the third, solve for x. Divide by 2, x equals whatever that is. 1,000 divided by 2, 500, something like that. So yeah, the definition isn't in there, but solving it is definitely there. Using the definition is probably going to show up. We still have time. We still have an hour and a half. What else we got?
20 and
20 as well as 21. Perfect. Thank you. Treg was a real quick last minute addition thing we did, which. Whew. Should copy this whole thing down there. 19 too? What is 19? Oh, wait. Yeah, we do need. No, we do need 19 for that. Yeah, you're right. The whole thing. Let's jump back to 18 as well. Let's do these unit circle stuff first, and then we can do that interest. Hang on 1 second. Screw it. I'm just gonna do it here. We have plenty of room. This is the last hour. Start with 19. We've got a point on the unit circle. And we got ourselves a little phrase that says x is equal to that ugly thing. Now, that ugly thing is not on our unit circle. That is not a memorized point. So if we're trying to find y, then we better have a formula that has x, y, and goes with the unit circle. Hold up. We do have a formula that has x, y, and goes with the unit circle. What's that formula?
X squared plus y squared equals 1.
Yeah? Has anybody ever looked up the formula for a circle? What is it? I think radius squared. I think, but I could be wrong about that. It might just be radius. I don't remember geometry class. Formula for a circle? Not area. Equation of a circle. There it is. Well, internet's not working. Equation of a circle. Ooh, x minus x1. This is an offset for your center of a circle equals, oh, it is r squared. Cool. It is r squared. But this is just like your hk from the other formula. Your offset for your vertex or your center or whatever you want to call it. That's kind of fun. Regardless, that doesn't matter. We have our x value, which is square root of 11 over 6. Square it plus y squared equals 1. Okay. I think we just got to do math. That's like the whole pre-cal part. That's done. That's the pre-cal step. This next step is the algebra step, which is actually tends to be the hardest step for most students. Square that whole thing, and you end up with 11 over 36, right? Plus y squared equals 1, which means y squared better equal. Anybody good at math?
So 36 minus
25.
36 over 36 minus 11 over 36, which is indeed, you can usually expect this to happen, a nice, neat square number. Especially if you're on the non-calculator section. By golly, expect nice, neat numbers. And if you don't get them, double back and try something else. Yeah, this would not be. This little one. Well, look at the 5. No, what's the root? No. 5 and 6 are good roots. Square root both sides, but hold up. We drew a square root, so we have to write plus or minus. This is really like the crux of that whole plus or minus. When do we use it? When do we not? Because this problem has both. They drew a square root right there. Did we write plus or minus? They gave us it. They told us this is a plus square root. If they would have put a negative sign in front of it, we would have known it was a minus square root. But because we drew the square root, we have to write the plus or the minus. That matters so much, more than I could even express. And I often get questions like, how do you know when to write it and when not to? It seems like we just pick randomly. It's like, no, it's just anytime we write it, we have to add it. But if the problem wrote it, we trust the sign that they gave it, even if that sign doesn't look like it exists. So that gives us y equals plus or minus 5/6. It's not too bad. But how do we know which one it is? Quadrant 4. Quadrant 4 every single time is going to be positive, comma, negative. Boom, there's our answer. Our y value is negative. Kill the positive sign. There's our answer. Y equals negative 5/6. I love this, man. Y'all, math's so fun. People just don't understand. You could just do this in your free time and you could have a lot of fun. And then you'd know math better and you'd have fun. It's like some people think playing basketball is fun. It is. If you could just learn to look at math the way you look at basketball, like, man, playing basketball is fun. Man, solving for missing coordinates of a unit circle is fun. It's like a puzzle or an Easter egg hunt. It's like an argument. It's like arguing with somebody. It's like, hey, I know there's a right answer. Let's get to it. That's fun. All right. So then, the point P in the figure, which I know it says left, it's kind of left, kind of up, has a y-coordinate of 4/5. Change the y-coordinate on us. Determine the following. Well, hold up. That doesn't make sense at all. But then you think back to the little acronym. What does Y kind of sound like? Sine. And what does X kind of sound like? No, it doesn't. But you got to remember those two. You got to remember Y kind of sounds like sine and X kind of sounds like cosine. Those are the related trigonometric ratios. So wait, I think we're pretty much done. What's the sign of that thing? What's up? It has a y coordinate. We just said sine and y are the same thing. So the sign of t is 4/5. Holy crap. Hold up a second. That means I know another thing without having to even move forward. The one that goes next to it. Which one goes beside sine? Cosecant goes with sine. I know it seems like it's wrong. Cosecant and sine go together. I know it doesn't seem right, but it is. Cosine goes to secant.
It's not there.
What? Oh, I know, but we're doing all 6. Anytime I see any problem, I know it's not. But I do all 6 because why not? Maybe you'll see something in one of them that you didn't technically have to write that helps you do the next one easier. Cosecant is 5/4. Right? You just flip it. You just take it and you flip it. So what's after sine? We go to cosine. This one we don't know yet. Crap, how are we going to find that? But how do we find it? I think we have to do the whole formula again. That sucks. Here you go. Your time to practice. X squared plus y squared equals 1. Go, go, go. Take 5 minutes to practice and yell when you get it, unless your name's Catherine. Power through, power through. Yeah, so it's a special triangle. Also, it's a special triangle if you remember that kind of thing. No, you said it a second ago. I thought I just heard you say it.
I was trying to do 25 minus 16.
9. You're right. What are you scowling about?
I think I'm not sure.
What do you think it is? 3?
12.
It's not 12.
No.
Hit Ricky. Wait. I'm hopping in. I'm racing you. 4 over 5 squared plus y squared equals 1. 16 over 25 plus y squared equals 1. Everybody's cool with that step? Y squared equals 1 minus 16 over 25. Everybody's cool with that step? Especially you people watching at home. Not doing that yet. Y squared. What'd you think? X.
I thought we were looking for.
Oh, shoot. No, we are. You're right. Hang on. Well, I just knew I was looking for the missing thing. Give me a break. Y and X. That better? Okay. Sorry. I did just not start doing it without even looking. 1 minus, 25 over 25 minus 16 over 25. 25 minus 16 is 9, I believe. 9 over 25. Got to square root it. So x equals plus or minus 3 over 5. And we know the quadrant still is... I think you're talking about that picture up there, which is in quadrant 2. That would make more sense. 4 wouldn't make sense for a sine chord.
Because it's point P.
Yeah. So that picture just got messed up.
I was talking about.
Talking about that picture. Oh, yeah, this wouldn't make sense if that was with 19, because it says quadrant 4, but it's in quadrant 2. In the picture, that's definitely going with this one. To the maths.
And then can you explain everything after
Yeah,
4?
100%. This one right here. Okay. I rewrote 1 as 25 over 25, because that helps me way more with subtracting fractions and common denominators, like pizza slices. If we have a pizza with 8 slices, and I'm like, hey, I want 3, and you're like, hey, I want 2, my brain real quickly can be like, oh, 5 are missing. But if you've got a pizza with 8 slices and I've got a pizza with 2 slices, and they're like, hey, I want 1, and I'm like, I want 2. Which one do I grab? Do I grab the half a pizza, or do I grab a slice? Like, a slice is not a good word. Then the slice is the numerator. Numerators aren't good without denominators. They have to have the same denominator. If you have 20 pieces lined up with all different slice cuts, like one has 1 slice, one has 12 slices, one is infinitely sliced, you can't just tell people to line up at a pizza and get 1 slice. It doesn't even make sense. That's what we did there. Is we had said we got to get the same number of slices. Otherwise, we can't make sense of the numerator, of the number of slices that you're going to take away. And then once you do that, 25 minus 16 is just 9. I guess the middle step there that we did within our brains was 25 minus 16 over 25. We combined the 2 tops over a common denominator. And then we said we want to get x by itself, so we got to square root it, which is what we did. If we square root it, we add plus or minus. We did a plus or minus. And where I was about to get to is we know quadrant 2 exists. So is it plus or minus for the x coordinate? Minus indeed. So we're looking at x equals negative 3 over 5. The square root of 9 and the square root of 25 are the other things you have to know. Like already is square root of 9 is 3. Square root of 25 is 5. If you remember back to high school, whenever you did triangles, you remember like someone ever talking about a special 3, 4, 5 triangle? It's another way you could think about it. If you ever see it, the 3 and the 5.
There has to be a 4.
Look at because look, what is the cosine? Negative 3 over 5. There's your hypotenuse for both. Your x and your y value. Okay, then how do you do tangent? Sine over cosine. 4 over 5 over negative 3 over 5. And fractions, keep the top alone. Change division to multiplication. Flip the bottom. KCF. So we got 4 over 5 is our keep. Time sign is our change. 5 over negative 3. Something cool happens there. Bop, bop. We end up with negative 4 over 3. Need to get our secant. It's just flip-flopping that thing. Need to get our cotan. It's just flip-flopping that thing. And that probably answers all three of the questions next to it, I believe. Yep, does it? Fun? No. Possible? Yeah. We want to do 21 as well or not? No. Oh, no, we should. No, we should because the pi values. Because that has unit circle memorization written all over it. So we just got to pick one of these. Do C? Okay, let's do C. But we're not just doing tangent. We're going to do all 6 values for that point. Cool? So on the unit circle, we have to think really hard about where is negative 5 pi over 3. And I know some people started moving backwards. I don't move backwards. I just would never advise you to do that. You know what I do before I start unit circling it? I never move backwards because I don't want to screw it up. I just add something to it.
2 pi.
I add 2 pi to it every time. No, it's not. It makes it easier and less likely to mess up, and then you can go look at your picture. Negative 5 pi over 3, you can't look at your picture. You would have to go like this. Negative 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. That point right there. So then you have to say it to be 1/2 comma root 3 over 2. That's hard to do.
That's the answer?
Yeah.
I would just.
What?
If you do it like that, then yeah.
Yeah, I was
It's
just like.
overcomplicated.
Yeah.
But how do you know where negative 5 pi over 3 is then?
You just reflect it.
Yeah.
Reflect what? I'm listening. You reflect what? Yeah.
Okay. 5 pi over 3.
Uh-huh.
If you just fold it over, you see that it's going to be 3 or pi over 3.
That's not where negative 5 pi over 3 is, though. It's not the y value reflected. This is the amount of distance you've traveled around the circle.
Yeah. So to get to
This is 5 pi over... Wait. 1 pi over 3? 2 pi over... Oh, I see what you're saying. Reflect 5 pi over 3, not reflect the opposite value. Yeah, that's fair.
you just draw a straight line up. And you're there.
Okay, well, I'm still going to add 2 pi. What? How else can you write 2 pi? 6 pi over 3? And you end up with pi over 3, which is the first chunk right there. I see what you're saying. Yeah, that's fine. I thought you were saying reflect the first quadrant to finish, like when you finish your circle by reflecting. Okie dokie. So now we have to ask ourselves, pi over 3, what point does that give us from our unit circle? 1/2 comma root 3 over 2. And from that point, we build our entire 6th name grid. The first being sine, the first being the one that you should definitely get right. The first 2 actually being the ones you should definitely get right every single time. Which of those 2 numbers is sine? Okay, and which one's cosine? Boom. Everything else comes off of those 2. Which one you want to do first? You want to flip it upside down first, or you want to divide them first? You want to flip them up over themselves first, or divide them over? Flip them? Okay.
I think you still have to do work for the.
You do have to work for all of them, except for flipping cosine. Because this secant is the only one you won't have to do any work for. Because what's the flip of 1/2? Just 2 over 1? Yeah, 2 over 1, great, which is just 2. Cosecant you have to do a little bit of work for. It's 2 over root 3, right? Which if you multiply by root 3, no, you multiply by 1. Root 3 over root 3. And what does that feed you? 2 root 3 over 3. That's called radicalizing the denominator or rationalizing the denominator. Getting rid of square roots in your denominator. Where you just multiply by 1 using your denominator. Now we got to do our little tangent thing. Tangent, the formula for tangent is just sine over cosine. Our sine is just root 3 over 2. Our cosine is 1/2. Keep, change, flip. Keep the top. Keep the top. Change division to multiplication. Flip the bottom. Wait, what am I doing here? I put it, that was weird. Times. Flip the bottom. Nice. Something cool happens. It's just root 3 over 1, which you're totally allowed to just write root 3. And then what do we have to do for cotangent? We go 1 over root 3. Ah, crap. We got to do our thing again. Root 3 over root 3, which yields us. Boom. Zoom out. There's the 6 things with the work that goes with it. But all of this is for naught if you don't have your unit circle memorized. I'm just thinking about just now.
I think there should be a hidden unit circle.
On the test somewhere or underneath everyone's desk. Like tape. I'm gonna come in 10 minutes early and tape a unit circle to the bottom of everybody's desk. Your fault if you don't feel for it. Oh, that's true. Yeah, I don't need tape anymore. I just need printed out unit circles. All right, what else? Let's say
Let's do.
let me look.
You're gonna write the formula on test, right?
Oh, yes. I'm gonna write the formulas. Your job is just to know, and I'm
Where to put it?
pretty sure it's on calculator. So that's pretty much that. Your job is just to know what does all the stuff stand for. So let's just do the save time by not doing it. Also, I did it on the video already. What does the 12,000 stand for? Thank you. Principal, capital, whatever you want to call it, what you start with. 5.6 is the R in the formula. But you have to write it as 0.0. You had to move it twice and fill in your zeros. Okay. What else we got? Per year, that means what? N equals. No, T's not per year. That's N. That means N equals 1. T is down here where you see. Well, look in a second. You'll see it for a second. After 3 years. That's a T. Compounded daily is your N. N equals 365. Well, that changes. That's a different. This is B. A, B, and C. I'm just saying, looking for all the keywords somewhere in here. Compounded monthly, what would your T be? 12. Compounded continuously. Different formula. ERT, I believe. AERT. Whoops. Not P. Wait, I'm so dumb. A equals PERT. Pert.
Okay.
And then if you want to go watch the video, I did do the whole thing, all 3 parts too. So I just don't want to waste too much time. I know half of y'all won't watch it. That's okay. I'm not mad. I'm just sad. But
I know these seem easy, but
no, don't say that.
no, because they do. But I just forgot.
Which one?
16.
16 doesn't seem easy.
Well, aren't they all like rules?
I mean, kind of, but that doesn't make them easy. Certainly, they're not easy if you're in 3rd grade. Right? Sure. The word easy is super relative. All right, let's see. What is this one? 16? Right? No. Okay. Top down. Gonna need some new pages in a second. Which one do you want to do first? We can do all of them, but which one looks the most like, I don't like that.
That.
You said, what?
Sorry.
Was that an answer to my question? The second one? Okay, how do we get rid of ease?
That one.
Yes. So how do you get rid of an e? You natural log the whole thing. But wait. What you do to one side, you have to do to the other side, right? Oh, lucky for us, there's an e there too. That's super nice. So what happens to that ln's and those e's?
They just
And you're left with 2 equals x squared. Your job now is just to go to town solving.
And if we do, or we keep both.
Answers? Yes. Unless we can do the next one. Unless you see a log,
wait.
then you got to check. Because logs can't have negatives or zeros. But e's, they can have every number in the world. So x squared minus 3x plus 2 equals 0. Which means x plus 2. Nope, that's wrong. You have to know how to factor. I apologize. So x equals 2 and x equals 1 are our answers. Both are super duper allowed. I believe. Should we check to make sure?
Or they check out.
Oh, yeah. Duh, they check out because the e's go away and you're left with what you started with. Yeah. I mean, it's always worth checking, but if you're running low on time.
Okay, now do the one that doesn't have.
D? D's the worst one because this one you get. Okay, here, I'll just do like how you do these. Just set these two things equal to each other for this one. Right? Because you're going to do log 3 on both sides. Cancel it out. So you should get x equals 25. For this one, you just got to move the 1 over and then log 5 it. This one is the weirdest one. 10x plus 3 equals 6 because they don't have the same base. So how do you get rid of something that doesn't have the same base?
You have to make them have the same base?
Yeah, but that's hard for this. Yes, that would be dope if you could. If it was like 2 and 4, and you could rewrite 4 as 2 squared, that would be sweet. This I don't even want to mess with trying to do that because 6 and 10 are weird. Which one would be prettier? Which base would be the better base? 10 or 6?
10.
Right, because then you could just write the word log and not even put the 10. So let's just do it and see what happens. See if the world likes us or not. My guess is the world's going to like us if we just start doing correct steps. So we're going to go log 10 on both sides, right? Log base 10. And something nice does happen right there. What? Don't say they. They's not a... Here's a question. Are we allowed to write 6 over here? You have to do the same log, right? You cannot just make up a new log because you want it to work nicely. You have to do good math. Okay, so only actually one good thing happened. The 10's canceled, right? So you're left on the left side with equals. Gasp. We've already talked about a rule that works for this.
You take the no.
Yeah. You do. You do exactly what you're about to say.
Oh, the 2?
Not just the 2.
That's your end.
This is an exponent, right?
Yeah.
Guess where it can go? And we get 2x times log of 6. I'm going to write log 10 just in case it wasn't a 10. Because who knows? Could have said 7. Oh, this is so mean, but it's a good problem.
Minus 3.
Yeah, don't you want to minus 3 or something?
I want a minus 3.
Divided by
Yeah, we got to get the x's out, huh?
divided by x.
You have to divide the log by 2x?
Divide the log by 2x, but then you're going to divide by x on the other side. You know what I would do? I'd leave the 3 alone.
I just converted that.
Move the x over here. Is that allowed? Now what cool thing can we do?
Divide by 3. No.
Can you condense and then convert?
Excuse me. Thank you. I don't think so. I think we want to get x by itself. And there's a cool thing we can do now if we get them on the same side. But they have to be on the same side to do that cool thing.
Oh, you can combine.
What?
Can't you like add them? I mean, after.
We go like this looks there, and that looks there, and what happens to it? Go shoop. Shoop. And now we're looking at 3 equals, what's out at front? Why didn't we pull anything else out front?
There's nothing else that looks the same.
Because there's nothing else that looks the same. Good answer. Second good answer is because we don't want to. We want x by itself, right? So what's left over after we pull out that x?
10.
Oh, crap. Good catch with that, too. I missed the 2. 2 log 10 6 minus 1. And you know what we can do with that crap? Just divide it out. Ends up on the bottom, and you're dunsies.
Is it really gonna be that hard on the couch, or is this just?
27.
I don't know. I don't think so. I think the test looks more like
A.
I don't remember, y'all.
How about the test?
I'm not gonna do that because I'm recording.
You did last time, and you stopped the recording.
It was a lot of work, and then I had to export it twice and then merge the things, and it wasn't worth it. I'm just gonna.
Or you can just mute the recording.
What do you mean mute?
Mute the mic.
It has nothing to do with the mic.
You can still see what's going on.
Yeah. And there's no pause button is the only problem. Unless you see a pause button. Could you hide the screen? Oh, shoot. I still don't trust this, but let's see. Then just scroll through it really slow. Oh, I'm not going to go through and look. Test 2. Test 2, part 1. We're looking at these log things. Oh, frick. That's, yeah, I muted on.
That looks pretty.
Alright, cash out $5 for that video.
That's good. Wait, what did we just do? A log?
Yeah.
Solving logs.
We just did
Find solutions
exponential
for
equations. Find solutions of exponential equations. There's not any?
There's still logs, but it's not like as explicit as what it looks like.
There's so much logs.
Yeah, well, we did it for a whole chapter. The main log situation that I would think about is, as I'm looking at it here, is like, let's do this next, is like rewriting the argument with it to have the same base. So like if you see log 3 of 9, your brain has to like, here, we'll do one in a second. And that's pretty much it. Okay, back to it. Boop. And boop. And so like, is there a rewrite the argument type thing question up above? Surely. Yeah, right here. Boom. Like if we're looking at C. Look at C. We got to figure out how to write C on 13. Sorry, I just jumped there without saying anything. 13C. Yeah, we are. If you look at 13C, we've got to rewrite that in terms of 3, right? So we got log base 3. Well, how do we rewrite that thing? That's a good first step. Now what? 3 to the third is 27. Log base 3 of 3 to the third to the 1/2. And now you've got 2 options. You can actually do one of 2 things. You could apply a cool log rule that we have to make your life easier. Or you could remember properties of exponents. What? No, kind of cross everything out.
How would you?
Oh, you're doing the exponent thing?
How would you apply it?
Where's that? Where's the biggest exponent?
Oh.
Where can this 1/2 go? Boop. And now we're looking at 1/2 log 3, 3, 3. What happens to log 3, 3, 3? Two of those cancel. Boop. And now you're just left with 1/2 times 3, which is 3/2. But wait, there's more. What if you went the other route? What if you said, I remember exponent rules. I remember that a to the b to the c is technically just what? A to the b times c. So I know that this is just log 3 to the 3 times 1/2, which is log 3 of 3 to the 3/2. And guess what cancels now? Boop. Oh, shoot. Same exact answer. Crazy. Can't tell if it's hot or cold in here today. Is it? All right. What else we got?
Nice, 9 to 9. Like what are the nines?
I want to do that. Okay, I've already done 9. So let's do a very similar thing. So we're going to do the sketch the graph and domain and all that crap, but we're going to do it with a thing that I pick that will help us. And then if you want to watch the video for both of 9, I've already done them both. Last class's video. But since I just went back and looked at the thing, I'm going to do a slightly more helpful one, I think. And by slightly, I mean very. Wait, how do I insert pages? Boop. Okay. Okay, so sketch the graph of the function and state its domain, range, and asymptote. All right, so here's what I'm going to say. Instead of those two functions, let's do these two functions. Let's do f of x equals 3 to the x, and f of x equals 3 to the negative x. Cool? I just made them up. And imagine if it was, what's the only other easier number than 3 that still yields a good graph? Does 1 yield a good graph? Because 1 to the 1 is what? And 1 to the 2? 1 to the 3? So that's not a good graph for what we're trying to do here. So if you were going to go study at home, the only thing slightly easier than this exact question would be a good thing to practice. But let's do this one. Sketch the graph. Well, this goes back to day 2 of class. We know how to sketch graphs because we do it all the time. Boop-a-doop-a-doop-a-doop. You just plug numbers in. But we're going to pick good numbers. We're going to be somewhat skillful with our picking of numbers. We're not doing the 1, 2, 3, 4 thing anymore because we're getting
3.
3 is a good number, but it's about as big as we want to get with our picks. So if we plug in 3, what do we get? 27. Okay, what else do we want to pick? Oh, I lied. We are just doing the 5 numbers. 0. Yeah, right. I'm dumb. What else do we want to plug in? 2 is 9. 1 is 3. 0 is undefined. Right? No! Freaking. What is 3 to the 0th? 1, not undefined. What would undefined be? Logs give you undefined. Exponents don't give you undefined. There's no bad exponent number. Otherwise, we'd have a 4th domain thing. Oh, I'm super out of room here. I'm going to split this in half. What about negative 1? 1/3? Negative 2? It's 1/9. So let's graph that thing. 0, 1, 1, 3, 2, oh, shoot, this is from the thing. This is the same thing from the M&M thing. And then the other one is from the reverse M&M thing. You remember what that graph looked like? Mm-hmm. If you plug the same numbers in, but into the negative x, I'll let you do that for practice, but it's going to look something like, that probably. I'll let you, if you're watching the video or you're just at home, go ahead and practice that. F of x and call that g of x if we want to instead of f of x. Plug in some numbers, see if you get it. But I'm telling you right now, that's about exactly what it looks like. I give you the table, I give you the graph, I give you two functions, and I say go to town. But I don't give you the numbers to plug in. I don't give you the x's to plug in, like -2, -1, 0. But I give you just about everything else you might need. And it's not a 3 there, it's some other number. So that's the same thing as the other one. Oh, domain and range. Crap. We need to say that. What's the domain?
All real.
0 or parentheses 0.
Wait, you're doing range. You're doing range. You're doing right, yeah? Domain is all real numbers. Range is
All numbers above 0.
yeah, sometimes they write this, all real positives. Don't do it. We're just going to write 0, infinity. Asymptote? Y equals 0 or x equals 0? I heard both. We're going to find x equals 0 is the line like this, and y equals 0 is the line like this. So I think it'd be y equals 0 because it's a horizontal asymptote, right? There isn't necessarily a vertical asymptote on it. They ask us for anything else? X intercepts and y intercepts.
There is
there it
only a
is.
y intercept, but no x intercept.
There is only a y, and it is at y equals 0, 1. There's no x intercept because that's the asymptote. It's called the y-intercept. Right. Oh, I didn't realize we just blew through our break like that. If you need to go use the restroom, just go to the restroom. Totally fine. All right, anybody got any more problems? Y'all see how this app is working fine now? Even with like simultaneously recording to a hard drive? It was literally just them being mean and saying, hey, we want you to upgrade or buy. That's so not cool. All right. What are we looking at? 4?
Question 2 is because all imaginary numbers as zeros result in a pair of positive and negative I.
Mm-hmm. So it'd have to be at least degree 8 to have those 4. What's up? No, it was just because if you have I as a 0, that looks like this. That looks like x minus I. And if you have x minus I as a 0, then by golly, you have to have the other one. Why do you have to have the other one? Because there's only one situation where you get that I, and it's a quadratic. It's a quadratic that has a square root. I'm not saying it's like, yeah, in square root always has a plus and a minus attached to it. And you say, well, the plus or the minus doesn't show up if there's a 0 underneath the square root. If there's a 0 underneath the square root, there's no I, because I got rid of that, where you get the I from. So, yeah.
For
That's
3, you just do the
TC over LC.
yeah.
Or grouping. If you remember, you can do TC LC for 3, but if you don't, oh, it doesn't. It looks like it should. You're right. I remember. I did that in the office the other day with somebody. Yeah, you just do TC LC. And then quadratic. After the first round, quadratic. Were you saying number 4, though?
No, I was saying
4, 2. I got you. What else?
How many drawings did we do? What was that?
8?
Yeah, we did
8?
18.
Oh, 18. We did. Okay, but no, wait, we didn't do 18 ever.
Yes, we did.
We did. You just said you didn't. You wanted us to see that because you already did it in your last.
Oh, yeah, we didn't do it. I just marked it up and said, hey, these are those things. We didn't actually solve it, though.
Since you did 1 of 14, can you do 1 of 15?
1 of 14.
No,
Lost.
you already did one of those. Can you do the, oh, we already did.
No, we didn't. That was from my other class. Let's do the one we haven't done yet. Though that one looks too long to do here. This is so fun. These are my favorite types of problems. Genuinely, out of all the types of problems we've done that are on this test or the test one,
There's gonna be an expanded and a combined number.
there will be at least one of each. I don't think they'll be as hard as this one we're about to do. This looks like pretty triple-y. But there will be, I'm telling you, at least one like combine-y stuff. Okay. The first thing I do, usually, is I do like the easier thing. Usually the first thing I do is like the one that is a quick, like, oh, I can do that real quick. Which is right here. And right here. Because that's just like quick one and done, and then you don't have to worry about it. So we've got log 2 of 3 minus log 2 of x cubed. Right? Because that just goes up there. Plus log 2 of x plus 1 to the 1/2.
So we're just like working backwards.
Yep. Basically just combining them. Which one do you want to combine first? The first two? Yeah, because they're there. And what happens when you divide something? Or, dang it. No, I just messed it up. Yeah, when two logs are subtracted, you can actually rewrite them as log 2 of 3 over x cubed. Plus all the other stuff stays the same. Haven't messed with it yet. Now what?
You can
If two things are plussed, then you multiply them. Log 2 of big old parentheses because we're getting kind of ugly now. 3 over x cubed times x plus 1 to the 1/2. Anything else to be done? Not really. Just rewrite if you want to, but that would be if you circled that. If you circled that, we'd be good. But if you want to rewrite it like this, it's a little prettier.
Oh, because of the fraction.
Because the fraction technically isn't this. Technically all over 1. Right? It's an invisible, but it's there. Multiply the top, multiply the bottom. Make that 1/2 a square root. That's just a little bit prettier looking if you're trying to be cool. What else we got?
1 on 17. Not 1, but like.
A problem? Yeah, I got you. Number 17 looks like logarithmic equations. It's what we just did.
Which one?
But no, I'm saying it's what we just did, but they threw an equal sign at you. That's the only difference. It's exactly what we just did. They just threw it. Let's do the hard one just because we might as well. It's very, actually, you can just leave it here. No, I'm taking it down there. It's because then we can look at what we just did. It's even log 2s like we did. It's literally the exact same process we just went through. But then at the end of the deal, they're going to throw an equal sign at us and like say, hey, what about if we equal that whole thing to 2? And it's a little bit, this one at least is a little bit easier. Can I just grab, whoa, don't do that. Can I grab all this? I don't want all of it. Shrink it. Move it over. Oh, we're slowing down. Oop, put these two next to each other. All right, so let's do it. Can you combine anything?
Yeah.
By golly, you can.
You can multiply. Right?
Yep. So we got log 2, x plus 2 times x minus 1 equals 2. Oh, shoot. How do we get rid of that log 2? It goes right here in this box. Got to figure out what goes in that little box right there. A 2 because of this base. And then what little symbol do you draw so you remember what you're doing with it? Draw the little caret saying we're raising the whole dang thing by 2. And you know what that does for us? Yeah, that's why we do it. And what you do on one side? Oh, look at that. 2 to the 2 is an easy math problem. X plus 2, x minus 1 equals 4. And now I think we're just freaking, do you know how to FOIL, factor, all that stuff? Do you know how to FOIL? X squared plus x minus 2 equals 4. Can you move that 4 over? X squared plus x minus 6 equals 0.
Positive.
No, because minus 4 minus 4.
What?
Minus 4 minus 4.
Positive 3.
Wait, did I screw up? Oh, you're saying what is the answer? I got you. X looks like minus plus 3 minus 2. Which means our zeros are negative 3 and positive 2. But wait,
There's more. You gotta plug them back.
because of the word log, we got to be careful. And we got to say, do these actually work? Well, let's plug in the 2 first because we know that one. Or that one's. If we plug in a 2, does all that look kosher? Like, can we do the log of 4? Yeah, I'll do it here. I'll do it right up here. Hang on. Log 2 of 2 plus 2 plus log 2 of 2 minus 1. Is all that allowed to do? Log 2 of 4 is fine, right? Plus log 2 of 1 is fine. But what if we plug in the other answer? What if we plug in negative 3? Log 2 of negative 3 plus 2. What is that? Holy crap. That's negative 1. That's bad. We cannot plug in negative 3, so we have to get rid of it out of our answer set and say that's the only answer. That doesn't happen with exponentials. That only happens with logs. Because logs introduce this restriction on the domain. Exponentials don't. All right. What'd you say?
I said we did all of them.
No, we did not. We didn't even touch the sine wave.
You know what?
Oh, there's no sine wave on it. Cool. That means it's not going to show up.
No, I think we did. Oh, no. 2. We just didn't do 7.
Lucky y'all.
What?
There should have been a sine wave on here. The thing we most recently did. You remember we did the wave situation for like the last class?
Yeah, yeah.
That's why I said lucky. It was supposed to be. But I didn't put it on the review, so I'm not going to put it on the test. So. But yes, it will be on the next test. Because I know for a fact it ended up on the final. I hate it. So maybe I'll do extra credit on this test. Put 1 as extra credit on this test. That way you can see it and know that it's not going to affect you. But you can see the type of problem.
7 or 8.
7 or 8?
Yeah.
Oh, frick. 7 is a good one. Because I've seen that before. I believe this is like a bigger chunk. So like, you know how some of them are like, just circle the answer. Like the last test, we had like the vertical line test stuff. We had like 8 of those. That's like a quick, like, does it work or not? And then there were some that were like, hey, you might have to work this out and it might take a whole page or so. This will be on the second half of the test and it'll take a whole page or so. So this is actually a good one to practice. I would put stars by it or something. But what I'm saying is like, in the timing of it, I've allocated 30 minutes of the test to this problem. So I'm saying this will be on there. Not these exact numbers. It's a 30-minute. This is a pretty brutal one. I think it is. I think it's pretty tough. Anybody got ideas where to start? Yep. Move everything, including everything. Get a 0 on one side. So we're going to say it actually is 0 less than or equal to 6 minus x over 2x minus 5 minus x. All right. Now what? So here's the steps. I'm going to write the steps because I know this is there. Move x that way. Step 2. Common. Nice. Denominator. I do have friends. Nah, it's just an alert. What are we doing? 6 minus x over 2x minus 5. What's our common denominator here?
2.
No. We'd have to multiply the whole thing by 2x minus 5 over 2x minus 5. So we've got 0 less than or equal to 6 minus x minus 2x squared, parentheses, minus 5x all over 2x minus 5. Distribute your negative sign, right? And do we have any alike terms or terms that are alike? 6 minus x minus 2x squared plus 5x over 2x minus 5. Yep, we do. So we've got negative 2x squared plus 4x plus 6 over 2x minus 5. Cool? All we've done is we've moved it over and got a common denominator. Step 3, the one that everybody hates, is factor. What's in common on the top?
2.
I'd take out that negative 2, make your life a lot better. Negative 2 comes out. You're left with x squared plus 2x plus 3. I lied. Minus, minus. That's like reverse distribution, right? We went zoop, zoop, zoop with a negative 2 over 2x minus 5. Is that a nice, easy factor? X minus 3, x plus 1. We're done. Not with the problem, but with setting up the solve. And now you just ask yourself, well, where are your zeros at?
Those 3.
I only see 2. Where are your zeros at?
3.
Your zeros are at x equals 3 and x equals negative 1, right? 3 comma 0, negative 1 comma 0. What happens at that other spot? The heck spot is it? 2x, 5 over 2. We got a vertical asymptote at x equals 5 over 2. Because that comes from setting the bottom equal to 0, right? Because 2x minus 5 equals 0. X equals 5 over 2 if you move all the stuff over. Boop, 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 boop. All right. What else? What were the other things we found? This comes from the first thing of the day. The y-intercept, maybe? What was that y-intercept? Freaking plug it in and see. I don't know. I don't want to plug this in. But I'm going to because it's important. Plug in 0 and you get negative 2 times 0 minus 3 times 0 plus 1 over 2 times 0 minus 5. And you get negative 2 times negative 3 times 1 over negative 5. So negative 6 over 5. There's 3 negative signs. So we did the same steps from before. We do your y-intercept, you do your zeros, you do your vertical asymptote, and that's kind of low, right? It's kind of like down here. Oh shoot! I think I know what that shape's gonna do. Actually, I got no clue what that shape's going to do, actually. Now that I think about it.
It has to go down because it's not like that.
Yeah. Oh, wait. We didn't do our horizontal asymptote. That's why. I was so confused. I was like, we haven't done our horizontal, or I was not understanding what was going to happen. We definitely need to do our horizontal asymptote, which is... Are they this? Oh, we need to go down here for it. There's your horizontal asymptote. Which one's bigger, the top or the bottom? Because the top is bigger. Is there an HA? None if the top's bigger. That checks out with the picture. I was really getting scared for a second. I was like, that doesn't work if it crosses and goes down. But because there's none, goes up like that. Probably out of line, but we're not getting into that. And how do we know what happens on the other side? We just got to pick one other point. You want to try 2? No, 2's on the wrong side of that line. 4? Let's try 4 and see what happens. If we plug in 4, we get f of 4 equals -2 times 4 minus 3, 4 plus 1, 2 times 4 minus 5, -2 times 1 times 5 over 8 minus 5 is 3. Really, all we care about is the negative or positive sign. We don't care about the number, but it is -10 over 3, right? So it's like down here. Oh, sweet. So what's that side going to do? Probably something like that. Fun little fact for you, which is we don't need for this test, but that's probably a line right there. So the answer is, where is all of that crap that we just spent all that time solving bigger than 0? Looks like right there, and looks like right there. So we have to decide how to write those two highlighted sections. And you're right, the blue highlighted section is -infinity all the way to -1. And then we unite that with the next section, which would be 5 over 2 all the way to 3. Boom, 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 boom. But that's actually 2 problems in one. That's this type of problem, but it's also the first type of problem we did, where you had to graph a, what's it called, a rational function. Like literally, once we got to that middle step, once we got the 0 on one side, right here, it became the first problem of the day that we ever did, which is just, can you graph a rational function? Can you draw your horizontal? Can you draw your vertical? Can you plot your x-intercepts? Can you plot your y-intercepts? And then find any extra little stuff to help you know where to draw the lines at. Which this one, it only took one extra thing we kind of see. And you can't add x-intercepts if they don't have them there. Like the reason you might be saying like, oh, well, how did you know it just goes up forever? Well, because there's no other x-intercept. I can't add an extra random x-intercept right here. That would be weird, and not in the math. So it had to go up forever. I can't add an extra one over here, so it had to go down forever, and that's how you know that you're on the right side of the thing. Okay. So I said that one is a little longer. It's 2 problems in one. It's moving this over is the first step and doing everything that goes with it. And then it's a graph of rational. And then the third step is kind of like, look at the graph and see what you see. Hopefully, whoa. Solve the following rational inequality. It's not a better way to do it. I wish there was. What's up? Just plug and chug table numbers?
No.
Oh. I guess another way
If you just solve,
for x?
yeah, if you just do your first steps different. So instead of moving the x over, you multiply by 2x minus 5, and then just add 6 or subtract 6.
And then look at that parabola?
You would just have, that would find your zeros, I believe. 'Cause I got
It,
-1 on that side.
those are our zeros.
You would just go back to the original, look at the denominator to get your asymptote, and then
Okay, and check
plug and chug to check.
points in between.
Yeah.
You could make a tape. You could make a small table with those zeros you found, and just put.
Just put X line. And then
That's fair. Yeah, yeah. That's what the table. Yeah, yeah. Another way you could do it is that parabola you just got with those zeros. Was it a happy or sad parabola? Because I don't have
Oh,
that.
I didn't even graph it all.
No, but you just look at the first number.
I erased
Oh, rats. Well,
Well, it would be happy.
okay. So watch this. There's your zeros, right? Happy. Where is a happy parabola bigger than 0? On the outsides. That's what we got there.
Yeah, you just have to
Oh, wait.
factor in the bottom
Asymptote.
and then you still get the same.
Mm-hmm. Yeah, the asymptote throws off a little bit.
Yeah, as long as you remember.
As long as you remember to go back and hit the asymptote with your number line like you did. Yeah. So I guess the other way to do it would be as soon as you get it, before you even do what you do with the zeros, as soon as you can get your zeros and your asymptote somehow, as soon as you can get zeros and asymptotes by any means necessary, put those zeros and asymptotes on a number line. So our 0 was -1, 3, and 5/2, and just pick a test point at each spot, 4 test points, and you're done. You could do that as well. I'd do like that.
That's what it was like. I'm gonna take a whole page.
But this is good review of how to graph a rational, and good practice graphing a rational. What? Stop this. It's 13 minutes, and it's the day before a test. What else we got? We didn't go over everything.
Well, we technically did, but we just like
we went over.
we went over one of each one. That's why.
I don't believe you.
Not saying we're like perfect.
Okay.
It's because they didn't give us any break.
We did one of every single one. I just checked them off.
We didn't do 4. We never did a TCLC.
Well, we never did these because you assumed we already know how to do that.
I don't assume that. I would never assume that. Let's do the royal you, not you. Let's do this. Freaking boom, factorize. Well, that's why we got to do it. All right, talk me through this, and then we can wrap up early if it doesn't take 13 minutes, which it shouldn't.
We had to find TCLC.
TCLC. Oh, but this is a pretty TCLC, isn't it? I think so. TCLC is literally just 1, 2, and 4, and what goes on the bottom? Yeah, that's not too bad. So we got to do plus or minus 1, 2, and 4. Send them. Tell me when 1, 2 works. You don't know. Send it. Do it. I don't want to waste all the space doing ones that we know don't work. I'll try -2. No. What works? As soon as someone tells me one that doesn't work, I'll do the next one. Okay, I'm gonna try 2 then. One does work. Yeah. 2, 1, -2, 5, -8, 4. Drop it down. You get 2, -4, -8, -3, -6, -14, -28. Oh, that didn't work, did it?
I did not for no reason.
2 doesn't work. 1 doesn't work? I'm hopping over to -2.
Nobody's trying 4?
No, I don't think so. 1, -2, -4, -8, -3, -6. What? It's ended up in the same spot? Positive 28. Oh, no, I screwed up the negative sign right there. That should be positive 8. Positive 8, 3, -6.
That's positive. Why is that?
Good night. Don't tell me that. What's 13 times -2? That doesn't look good anyways. Okay. Wait, does none of them work? Something has to work.
Probably.
Otherwise, it's not solvable. 1? Oh, you were the rats. I said I was going to be mad. 1, -1, -1, 4, 4, -4. Dang it. Check. Here's the step of what's the hard step that I actually have more, find more problems with or misconceptions with than usual. What do we do once we get that check mark? We're going to populate it with
We're gonna
x cubed, x squared and a plus sign, x, leave the minus sign, and there you go. So we've got x cubed minus x squared plus 4x minus 4. This one's going to do grouping. We don't even have to be smart. Take an x squared out, and you get x minus 1. Take a 4 out, and you get. And now what do you do with those 2x minus 1s? You literally do the same thing, but with the longer thing and take them out. And now you've got x minus 1 all outside of whatever's left in red. X squared plus 4. So we've got. Oh, we missed our first thing. We should have an extra factor sitting on top of there.
Shouldn't it be a -4 instead?
No, where does our... Let's just keep going and see. How do we get the zeros from x squared minus plus 4? You set it equal to 0, and you get x squared equals -4, right? So x equals square root of -4. So x equals plus or minus 2i. Okay, so there's our zeros so far. We have zeros of 1, right? 2i, -2i. But wait, we're supposed to have 4. We're supposed to have 4. Why are we supposed to have 4 from the problem? How do we know we're supposed to have 4 zeros? There's a 4 right there. Where's the 4th zero at? It's here. It's hanging out. Look at the whole problem and tell me where the 4th zero is at.
Is it where it says x minus 1 twice?
Well, that's the first x. That's this thing right here, right? That's that. That x minus 1 twice? That's right there. And that's where we got that from. That's where we got our x equals 1, 0 from. Where's the other 0 at?
Is there multiplicity?
Yeah, that's the word. One of them better have a multiplicity if we don't have any other zeros. Which one better have a multiplicity, probably? Where is it accounted for then? Where? I see it here, and I see the other 2 in red down there. Where is that last one accounted for? There's a 0 that we didn't circle or account for or write it in somewhere.
Oh, is it the first one up there?
Where?
The one
Where?
at the.
Yeah, no, it is. Where is it?
It's the one that we did with the.
The one we did in dividing, right?
Yeah.
Boom, boom, boom. There's the second one. So now if we go to write our whole thing, our p of x, we have 1 x minus 1 from the very top. We have 1 from the grouping situation. And then we have x plus 2i, x minus 2i from the factoring. So it is important. And then, yeah, you're allowed to write that the cool way, which is square it. Because that has a multiplicity of 2. Okie dokie. Don't forget your calculator. That's really the only thing to not forget. Don't forget your calculator for half of it.